Like all other animals, humans exist in a world that obeys the laws of physics in which unsupported objects fall to the ground. Solid objects cannot pass through one another, and getting from A to B requires one to pass through all of the points in between. Understanding these and many other physical principles is essential if the individual is to negotiate the world in an effective manner. If evolution has shaped the way that the mind works, we might expect such understandings to emerge early in life. The Piagetian infant has no understanding of physics. This is, however, incorrect, as all clinically normal children have an intimate understanding of the physical world. Not the school physics of inclined planes, frictionless surfaces and masses which take up no space, but the common sense physics that enables us to move around the world, throw things, use containers for liquid, and reason about the behavior of objects. It has been suggested that it is our deep understanding of common sense physics that makes learning school physics so difficult. Since the real world does not have frictionless surfaces, air resistance is a factor in most interactions, and concepts such as heat and energy have formal interpretations very different from their meanings in common language. Learning school physics is hard because we first need to unlearn our intuitive physics. One of the most basic assumptions of adult physical knowledge is that objects endure independent of our ability to perceive them, something that was investigated by Piaget and is known as object permanence. Although not an empiricist, Piaget believed that the infant has to learn practically everything about the physical world, even the basic assumption that objects continue to exist when they are out of sight, which is object permanence. Piaget was led to this position partly because his theoretical starting point was to assume as little innate knowledge as possible, and partly because he believed that he had evidence for it. But not being an empiricist, the evidence happened to be questionable. In one of his studies, an infant is seated opposite a desirable object, such as a soft toy. Under normal circumstances, the child shows interest in the toy and attempts to reach towards it. If an opaque screen blocks the view between the infant and the toy, the infant quickly loses interest in the obscured object as if it had ceased to exist. Older children behave differently. They simply reach around the screen to retrieve the toy. Piaget's interpretation of these results is that to the infant, the object no longer exists, which is very different from adults' understanding of the physical world. Adults know, or at least believe, that objects continue to exist independently of our ability to perceive them. However, Piaget's interpretation of the results do not demonstrate conclusively that the infant has no understanding of the permanence of objects. For example, the hidden object might simply have become less salient. The infant simply forgets that it is there. Alternatively, maybe the infant knows that the toy is still there, but does not know how to go about retrieving it. Piaget's original study is therefore inconclusive, since there are a number of alternative accounts other than the radical one that the infant believes the object has disappeared from existence. Recently, techniques have been developed which enable us to probe infants' thought processes in a more systematic way using techniques such as habituation procedures. Habituation procedures allow us to have insight into the minds of infants by capitalizing on the fact that infants, just like adults, eventually find repetition boring. If the same thing happens repeatedly, then no matter how interesting it was initially, the infant slowly loses interest and indicates this lack of interest for all to see by averting its gaze from the repetitive stimulus. We can therefore think of habituation as learning not to attend to a stimulus. In an example experiment, if we present a stimulus, say for example a short animation, repeatedly to two groups of infants, they will eventually show signs of boredom. We then present each group with a different animation, call them animation A and animation B, and measure the amount of interest, specifically how long they are looking at the animation or how long it takes them to become bored. Suppose that the infants who had animation A showed significantly more interest than those receiving animation B. We might therefore assume that animation A was seen by the infants as being more different from the original animation than animation B. Of course, in the study described, perhaps animation A was just more interesting to all concerned than animation B. So the study will have to have various control conditions to rule out such possibilities.
Just down the hall from Carl, Renee Bayerjon is finding out when that sense of the possible begins to develop. Renee's group puts on magic shows for babies. with results that have astonished her colleagues around the world. Each show tests whether babies know some basic physical rule, that objects can't just disappear, for example.
If babies have the knowledge, they will be puzzled or surprised or intrigued by our magical events. And we know when babies are surprised or puzzled, they tend to scrutinize the events, to look and look and look at them. And so what we do in our experiments is compare infants' responses to magical events and non-magical or real events to see whether they look longer at the magical than at the real ones.
As Holly's attention is captured, a hidden observer starts the timer. This time, it's a non-magical, normal event. The 3-month-old is soon bored. She looks away, and the clock is stopped. Now for the impossible or magical event. Holly stares. She really scrutinizes the event. That means she's surprised. Even at 3 months, she knows the world doesn't work this way. Backstage, there's a simple explanation. 2 dolls moved independently. But Holly is riveted and even startled by such an illogical sight. Over many trials, 3-month-olds have been consistently surprised by the disappearing doll trick. They all seem to understand it's not possible. But take a look at the next result. Babies like Felix, who were just 2 weeks older, were not surprised. Renee concluded that their worldview was more sophisticated.
These babies spontaneously came to the conclusion that we were using 2 different objects, 2 minis, to produce the event. And so what we did to test this interpretation was to lower the screen at the start of each event. We say, no, this is not what's going on here.
Okay, he thinks, I see they've got just 1 doll up there. But unknown to Felix, when the arch is raised, the second doll is slipped back in. And once again, these slightly older babies were back to being surprised, which seems to confirm Renee's conclusion that they had figured out the original trick.
This diagram shows an outline of the basic representation of some other experimental equipment used to test object permanence. The infant is seated opposite a device in which a screen rotates through 180 degrees away from the infant. Video cameras are focused on the infant's head to enable the time the infant spends looking at the screen to be measured. The screen moves through its cycle over and over again until the infant shows signs of boredom by looking away from the screen. Following habituation, a block is placed behind the screen of a height such that it is clearly visible to the infant as the screen starts to move up, but becomes obscured when the screen is at about 60 degrees through its rotation. Once the block is in position, the screen is again rotated. In alternative 1, impossible event, the screen continues to rotate as if the block were no longer there. In the alternative 2, possible event, the screen stops at the point at which it would make contact with the obscured block at 112 degrees. Interest of the infant is measured by time looking, since they cannot voice their interest directly. Think of what Piaget's theory would predict. The Piagetian infant, remember, believes that once something is out of sight, it no longer exists. If this were the case, then the infant should not be at all surprised by the impossible event, since the screen rotating through 180 degrees in the test phase, as soon as it is obscured by the screen, ceases to exist and cannot therefore stop the screen. The Piagetian infant should find the possible event where the screen stops more interesting, more surprising, and garnering more attention time, since this is more different from the habituation phase, because the screen would appear to be stopping for no reason and being perceptually more distinct. The figure on the right shows the responses via looking time to the experiments with the apparatus at the left. The habituation trials show looking times decrease as the babies become bored. The right-hand panels show looking times in the test phase. Babies look longer at physically impossible events where the box apparently disappears than at physically possible events where the screen is stopped by the box. The infants attended longer to the 180-degree impossible event condition than to the possible event condition, where the screen was stopped by the obscured block, indicating that this was surprising to them. Just like adults, infants expect objects to endure even though they are out of sight, something that is in sharp contrast to Piaget's prediction. Using habituation techniques, Elizabeth Spelke and colleagues have suggested that by 4 months of age, infants have a number of expectations of the physical world, which she refers to as principles. These principles state that objects move as wholes on continuous paths. In other words, objects maintain their shape, and if going from A to B, have to pass through all the points between. This could be called the no teleportation principle. Objects cannot pass through one another or occupy the same point in space or time. This could be called the no ghosts principle. Objects cannot act on each other unless they come into contact. This could be called the no telekinesis principle. Infants are not born with all the principles that they will eventually possess. Some learning must take place. For example, Spelke et al. Found that 6-month-olds, having been habituated to an object falling onto a platform, were surprised when on a test trial the object subsequently came to rest inches above the table. 4-month-olds, however, showed no such surprise, indicating that their knowledge of gravity was not fully formed yet. The early emergence of knowledge of the physical world might be taken as supporting the existence of an innate physics module. This early knowledge of how the physical world operates is by no means a talent unique to human infants. Psychologists Mark Hauser and Susan Carey have shown that the adult cotton-top tamarins have similar assumptions about the physical world to those of a 5-month-old human infant. These similarities between non-human primates and human infants should not be too surprising, since the survival of both animals depends upon an understanding about the way that physical objects behave, and is therefore likely to have been influenced by natural selection. Human infants, therefore, may be well born with certain expectations about the way the physical world operates. This makes evolutionary sense. Imagine a population of infants who have no fear of heights. Now imagine a genetic mutation arises in one individual in this population, which provides that individual with a seed of fear of heights. If having this fear of heights increased the infant's chances of surviving to maturity compared to its peers, then it can be seen that such a mutation would, over a number of generations, spread rapidly throughout the population.